In 1968, the first head-mounted display was invented for an immersive experience of computer graphics. In the past few years, virtual reality has a significant growth in popularity in the consumer market. While these devices have made decent electronics and optics, the next generation head-mounted display should also focus on the perception side for a comfortable viewing experience. Let's say a real-world object emits natural light rays, which is called a light field. These rays propagate to the observer, and the eyes focus these rays to form a sharp image to the brain. Objects farther away has a very different statistics of the light field, allowing the eyes to sense a different depth. Together with binocular vision, we perceive a three-dimensional sensation. However, traditional head-mounted displays in the current generation can only provide a single display plane. Without a proper focus cue, the display decouples the accommodations from the vergence of the eyes. Since there is a mismatch, we have to rely only on the binocular vision to feel a three-dimensional space. The result can lead to visual discomfort and fatigue, eye strain, diploptic vision, headaches, nausea, and even lead to pathologies in the developing visual system of children. In this work, we present a light field stereoscope that generates a natural light field with real depth information for the eyes and the brain to form a true three-dimensional perception. Instead of rendering a depth of field effect onto the screen, we really let the eyes perform the natural refocusing and enable the brain to perceive a comfortable and true immersive experience. Compared to the prior solutions using integral imaging and additive layers, our solution provides the first high-resolution and high-quality head-mounted displays with real-time rendering. Our goal is to build a head-mounted display that can emit the true light fields. In addition to the original components from a traditional head-mounted display, we only add a spacer and a second display panel. We leave the rest to the computations. We factorize one 4D light field for each eye in real time, such that two images are to be shown at the front and the rear displays. Since we set the two panels work in a multiplicative manner, a 4D light field is reconstructed in an optical way for the eye to truly focus. Here we show some results captured using a camera with 5mm aperture, simulating the human eye. The camera can change its focus front to rear without a problem, and we can control the 3D scene in real time and still be able to focus. Here is another scene with more prominent front and rear objects, and the camera has no problem to refocus. In many virtual reality applications, object manipulation with hands is commonplace, and be able to accommodate within this range is critical. And there are more scenes showing refocusing. Here we show the bench scene with a lot of high frequencies in both the foreground tree and the background bench. Finally, our display does not just provide a platform for gaming, it can also be used for cinematic content creation. In the past few years, there has been product of light field cameras and research of light field content editing, and our platform completes the end-to-end pipeline from the content creation to the content presentation. Here we show a refocusing example of an image captured using a light field camera. The eyes can focus at front or at rear without recomputation of the image. To further enhance the experience, we use a translational stage for the camera to capture a stereo light field, and the different focusing planes help the eyes to converge and diverge more naturally and comfortably. In conclusion, we show that human perception is the next important step for the development of a comfortable viewing experience. We present an inexpensive and simple modification to the existing head-mounted display, allowing it to emit a light field. Our solution not only allows the eyes to focus naturally, but the implementation also enables real-time frame rate. We also demonstrate cinematic content using a light field camera. We believe this work to be an important advance toward the vision of making virtual reality a reality.